Okay, good afternoon, everyone. It is Oihik Mitra once again. My introduction is I am an information security analyst and ISOEH. So, as you all know, our today's agenda is concept of NAT in networking. Okay, so the full form of NAT is the network address translation. So there is a word called translation here. Now, why translation? So before jumping into NAT, we have to know about two things. Now, two things means we have to know about two types of IPs. That is, one is private IP, another one is public IP. So what is this? Private IP is that those IPs which is provided to us by our ISP, that is Internet Service Provider. For example, Alliance, GeoNet, GeoFiber, then WishNet. Okay, there are multiple ISPs are there. They provide us the private IPs. Now, why they provide us the private IPs? Why? I mean, what is the use of the private IPs? Using the private IP, we communicate inside a network. Okay, inside a network. Only inside a network. Okay. So, and private IPs, the ISP buy from IANA, ICANN. Okay, there are two organizations which is working together. Okay, but using the private IP, we use to communicate inside a network. Okay, but if we want to access the internet, we need to use the public IP. Okay, we need to use the public IP. So public IP doesn't come in a different way. Our private IP has been translated to a public IP. Let me give you an example. Suppose when we are in our home, we are in a room, then obviously we will be in our homeware, right? In our home clothes. But if we want to go or if we have to go to or outside our home, then we have to change ourselves. We have to wear outdoor clothes, right? Shirt, t-shirt, like fresh t-shirt, right? But are we changing our characters? We are not changing our characters, obviously. We are just changing our clothes. That means what? We are translating ourselves, right? In the same way, just think private IP as your home clothes, okay, and public IP as your outdoor clothes. So, in order to access the internet, that means you are going outside your from out you have to go outside your home network or in your internal network. So, in order to go outside, you have to translate your private IP into public IP. So without using the public IP, you cannot access the internet. Let me give you an example. So for that, let me share my screen. Okay, I hope my screen is visible. So in the CMD part, if I check my IP using if config command, you all know. See, my IP is now 192.168.100.20. So this IP is our private IP. Using this IP, we will communicate inside our LAN or inside our internal network. But now I am connecting to I am connected to the internet. I am now using the internet. So if you go to the internet and if you check what is my IP, so if you check the IP, see your IP is different. If IP is different, here your private IP is different. If you compare these two IPs are different. But these two IPs not different. It these 122.163, these IP has been translated from this private IP. Why we translated that? In order to use the internet or the global internet. You have to go outside. It just changed its clothes. Nothing else. It just changed its clothes. It just translated itself. Okay. Now, private IP is non-routable. Non-routable means, what is the meaning of routable? Routable means if we want to move to, or if we want to communicate in a different network, then we need a router, right? Now, router helps to perform routing. Okay, routing means it will create a path from my network to the network with whom I want to communicate. Okay, so this, so using the private IP, we cannot do the routing because it is non-routable. Obviously, using the private IP, I cannot use the internet. I have to use the public IP. So public IP is routable. Okay, public IP is routable. Now, how can you know that with what is the public IP? I mean, which ranges is actually is my private IP and which ranges consist of the public IP? So I am giving the list. Okay. Okay. Now I am giving the list of private IP addresses. Okay. Now we all know that IPv4 has been classified into famously three parts, that is class A, class B, class C, and another two parts is class D and class E. So for the time being, I am giving you the private IP address of class A, class B, and class C. Okay. Okay. Now, what is the range of class A private IP? It is 10.0.0.0 to 10.255.255.255. Okay. Now, what is the range of class B private IP address? 172.16.0.0 to 172.31.255.255. And what is the range of class C private IP addresses? 192.168.0.0 to 192.168.255.255. So these are the ranges of private IP addresses. Okay, so any IPs which is not falling in these ranges is, we will be considered as public IP. Okay, suppose if we consider a public IP of class A, let me show an example. Suppose 11.0.0.2 class B, suppose 174.0.0.5 class C, it can be 194.0.0.8. Okay, so these are the examples of public IP. Okay, so now if you see your IP is suppose this, IP is suppose with this range, you can make sure that these IPs are your private IPs. But if you're seeing your IPs is like this, then you can make sure that means these IPs are not falling in this ranges, right? That means these IPs is falling under the public IP. Okay. Now what is the benefit? Now what is netting? What is NAT or netting? NAT is nothing but, I have told you about this translation, that translating from my private IP to the public IP. This translation is called netting. That is why the full form is network address translation. Okay. So network address translation. Okay. So what is this? Translation of private IP to public IP. Okay, now what can be the benefits of NAT? If we tell about the benefits, then you can say number one benefit is IP addresses will be reused. Now, why? So, what we know, a particular IP for private IP, I am talking about now private IP, this one. A private IP will be unique inside a single LAN. Suppose in a LAN, I have a IP called 192.168.1.200. So within that LAN, nobody can use this IP because it has been registered in my system. Yes, if I disconnect my connection, then this IP will be free. That's a different matter. But when I am connected to the network, that time this IP cannot be used by anyone else. Okay. So now, if there is no term called public IP, if there is only private IP, just think what can the problem. This IP, if I am getting this IP 1.200, that means what? This IP has been registered against my name in this whole world. Nobody in this world cannot use this IP. So there is a IP wastage. Okay, IP wastage. So we all know IP4 is less. IP4 is less, like near about 4 billion, and we have a world population of 8 billion, near about 8 billion. Okay, so 4 billion is the number of IP address in this whole world. So if I use IP4, like AP for private IP, and there is no concept of public IP, so there will be much shortage of IPv4 in this world. So what it is doing, using, if I translate this particular private IP into my public IP, suppose this one, that means what? This IP will be unique in my own LAN, in my own network. Okay, the people who will be present in my network cannot use this IP. But if we go in a different network, we can get us we can get someone that who is using this IP. Why? Because my particular this 1.200 has been translated publicly, translated to particular public IP. So anybody who is present in a different network, not present in my network, can use 1.200, right? So this is the first advantage. That is, IP address will be reused. So my mistake, it can be reused. Okay. Number two is protection from malicious hackers. So what does it mean? Suppose if there is, I am considering there is no concept of public IP. I am using internet using my private IP. Okay. So just think, my private IP has been exposed through to the global internet, right? So anybody can see my IP. So if there is someone among numerous people, if he or she is a malicious hacker, then easily he or she can send any malicious packet to me. And if he sends any malicious packet, my whole network will be collapsed or become poisonous, right? So this is the part. This is another advantage. We can hide our private IP by translating it into the public IP. Okay, so these are the two benefits of netting or NAT. Now, if we say about disadvantage, sorry. Okay, if we talk about disadvantages, what does it mean? That means why we shouldn't use public IP. Okay, or why we shouldn't use a NAT. Why? Because If we say end-to-end delivery is not possible, not possible, not is difficult. Why? Because it is translating itself from private IP to public IP. Then it is delivering, and there are multiple networks in the internet. There are multiple, innumerable, billions of network which is present in this global internet. So might be it will be difficult to perform a end-to-end delivery using the NAT. Next one is, as I have told, the private IP will be translated to my public IP. So there might be delay in communication. Okay, might be delay in communication. Okay, so and obviously sometimes difficult to manage. Okay, because there are multiple private IPs which have been translated to multiple public IPs. So, if we see in perspective or on picture of network admin, so for him it might be difficult to manage the all these public IPs and private IPs. Okay, now we will move to types of NAT. Types of NAT. First one is static NAT. Second one is dynamic NAT. Third one is a part of dynamic NAT, that is PAT. Mainly there are two types of NAT, static and dynamic NAT, but there is a third type of NAT also which itself is a part of dynamic NAT. We call it PAT. Okay, so PAT means port address translation. Okay, now what is the difference between static NAT and dynamic NAT? In static NAT, there should be as much of public IP needed in accordance to my private IP. Suppose in my network, there are 10 private IPs are there. Okay, so in a static NAT, if we are going in static NAT, that means we need to have 10 public IPs over against my 10 private IPs. Okay, so what is this? There must be as many public IPs as there are private IPs. For example, I am opening Excel. Okay, now what is the disadvantage in static NAT? Okay, in a static NAT, the network admin will manually feed and translate all the private IP into public IPs. Suppose what I have told, I have 10 private IPs. Suppose I am making a list private IPs. Okay. And public IPs. Okay. Now let me make a list of 10 public IPs. 80.1, 0.2, and I am dragging it. So I'm making till 10. Okay, I have 10 public IPs. Now let me use the public IP. Suppose T dot. Now, okay, let me explain first. Now, what I've told, there must be as many public IPs as there are private IPs, right? So there are now 10 private IPs over there. Now I need 10 public IPs. Okay, this is just getting that, but there is another disadvantage of static netting. What? If we see in perspective of network administrator, that means he has to manually seed and configure the private IP with my public IPs. That means what? Suppose I am a network admin and I have a list of, suppose I have a list of public IPs and 10 list of private IPs, right? Let me track. I have a list of these public IPs. I have my list. So what I have to do in static, if we go into static net, then we have to manually set and configure. That means if we, I have decided to translate this private IP into 0.1. Okay. So whatever I will manually write 50.0.0.1. I have to manually write 50.0.0.2. I am manually writing 50.0.0.3. So this is how we have to write manually or have to configure manually translate my private IP into public IPs. Okay. So this is a very hectic task. Why hectic task? Because if we tell about, if you talk about a company perspective, there are 100, 200 systems in a network, right? So it will be very hectic task for network admin to manually seed and translate each and every private IP into the public IPs. Okay, so this is all about static NAT. Okay. Now, what is dynamic NAT? Dynamic NAT means in a dynamic NAT, one problem has been solved. I am coming into that. In a dynamic NAT also, and which problem has not been solved? That problem. Which problem? In a dynamic NAT also, there must be as many private IP as there are, as many public IP as there are private IPs. This problem still persists in dynamic NAT. But which problem has been solved? In dynamic NAT, the network admin does not have to manually seed and configure the private IP or configure and translate the private IP into public IP. So what you have to do? He just give this public IP, he list a public IP to the NAT agent. Okay, to the NAT agent, and the NAT agent will itself translate the private IPs into public IPs. Suppose it give 1 minute. Okay. For example, the NAT agent automatically will translate the private IP into public IPs, right? So suppose it has translated 0.1 into 50.0.0.9. If we translate 0.169.8.0.0.2, post 50.0.0.5. Okay, so the network admin here is not manually translating the private IP into public IP. The NAT agent will automatically or itself will do that task. Okay, so this is all about dynamic NAT. But one problem is still persist, that there must be as many public IP as there are private IPs. If there is 100 private IPs, there should be 100 public IPs. If there is 200 private IPs, there should be 200 public IPs. So this is a major problem still there. And also it will vary more cost, because the ISPs will have to buy each public IP with huge cost. So if they have to buy 1,000 public IPs, then the company will go down, simply go down. Okay, so this is the scenario still. So this is a problem we still persist. But now there is a modern type of netting. It is a part of dynamic netting that is called PAT. That is port address translation. Port address translation. Now what is this? This will mitigate or this will overcome all the limitation which we have seen till now. What are the limitations in static and dynamic net? What is the most common limitation? That there must be as many public IP as there are private IPs. But in dynamic net, one problem is solved if we see in the perspective of network admin that he does not have to manually sit and translate the private IP into public IPs. The NAT agent will do that automatically. But in a PAT, the first problem has been solved. How? If you see the full form in PAT, port address translation. Now, why port is coming? We all know there are 65,535 ports. Okay, 65 total of 65,535 ports present in this world. Okay, now what is the scenario in PAT? We can say logically 65,535 ports can be associated with a single public IP. So logically if we think logically if we think 65,535 ports can be associated with one public IP. Now see the thing. I have one public IP and I am using that one public IP with 65,535 port. That means logically 65,535 IPs or private, to be precise, private IPs. So see, that problem has been solved. Which problem? The first problem. What was the problem? There must be as much public IP as there are private IP, which is present in the dynamic net and static net. But in this PAT, this problem has been solved. Okay, so I have to the what the ISP will do? They will just buy one to two IPs, one to two public IP, and those public IP will be associated with all its customers. So it is a cost saving advantage. If it was the benefits, number one, cost saving. Number two, don't have to manually translate, right? Okay, so this is the scenario in PAT. Okay, now in PAT there will be one public IP, right? So if you say I am talking about real life scenario, if you see these public IP and if you also like looking from your home and if you're using same ISP, that is Airtel, Bharti Airtel, okay. So if you are also using Airtel, I am talking about the audiences who are using Airtel, okay. So please see what is my IP. Just search what is my IP in the Google and check the public IP. It might be same. Why? Because we have the same ISP and all the ISP is now using PAT. Okay, dynamic net, static NOT is not being used. Okay, they are all are used PAT. All are using PAT. Okay, so this is all about the theoretical part of netting. Okay, now let's move to the practical part. Okay, so in the practical part, I will simply use a simulator software. I think you all know that is Cisco Packet Tracer. So those who don't know about the Cisco Packet Tracer, let me tell you, it is a simulations tool. Like simulation tool means like we play simulation game like bus simulator, truck simulator, where we get the features of real life scenario like gear, accelerator, right? Okay, so here also it is a network simulation tool, not a network simulation tool, it is simulation tool which will give us the experience of configuring the network devices like we are doing in reality. So see, it has multiple devices like routers, wires, then computers, smartphone, TV, everything, each and everything is there, and multiple options are there. Okay, now let me make a static net. Okay, let me bring a router first. So one router. Okay, another router is here. That's it. And I need a switch. And so, okay. So let me bring some pieces. Let me bring four pieces. And I will connect each and every pieces with this switch. That means this is my LAN network. And suppose this router is my ISP's router, and my LAN is connected to the ISP router. Okay, and this will make global internet. Okay, so okay, so you have to connect to router, to turn it off and bring the port over there and turn it on. For the same also. Okay. Okay, so all connected. Let me mark it. 1 minute. So suppose so for example, this is my ISP's network. Okay, and this network can be okay, this network can be a global internet. Sorry. Mistake. Okay, so I have to connect a device with this. Suppose I am connecting a server. I am connecting a server with this. Okay, so this is a scenario here, and I will write this is my suppose I'm using Alliance ISP network, Alliance ISP. Okay, and let me allot the IPs first. So Let me write. I'll be a lot. Suppose 1.10. Okay. 2.168, 1.11, 2.168, 1.12, and this will be 2.168.13. Okay, now this public IP will be in, suppose 50 dot, dot 1, this one, and this will be t dot 0 dot 0 dot 2, and this will be the outside network, right? Outside network. Outside. And its inside network will be 2.168.2.1, and this IP will be 2.2. That's it. Okay. So this is my scenario, and now let me provide the IPs which you have written. So go to desktop, IP configuration, 58.1.10, 192.168.1.1 default gateway, .8.8.8. That is my DNS server. Same also in the second PC, we'll simply go to desktop, 1.11, 68.1.1, 8.8.8.8. Okay. 168, 1.12, 68, 1.1, and DNS will be same, 8, and this will be 13. 1.13, 8, 1.1, 8, 8, 8, sorry, 8. Okay, so work. Now we have to provide the IP to the router also. Now, how can you provide the IP to the router? Just go to the CLI mode and just provide it out here. Okay, so no and enable and config terminal. Okay, now we have to go to the interface, that is interface FA0 by 0. The interface name, I'm showing it to you, the interface name, that is this one, FA0 by 0. As you can see, so to go to the interface name. Okay, then IP address 2.168.1.1 followed by subnet mask. Okay, and you have to write no shutdown. If what it means, no shutdown means by default it is shut down, it is turned off. We have to turn it up by saying no shutdown. Okay, right? No shutdown. Okay, so it is done. See, it has been turned to green. Now we have to provide another IP2, that is 50.0.0.1. Let me check the interface. That is AC01 by 0. Okay. Now, okay, let me close it. Exit like int AC01 by 0 IP address, sorry, 50.0.0.1 followed by the subnet mask 255.0.0.0. Okay, no shutdown, same. Okay, so this part is over. Now I have to move to this part, right? So let me provide IP to this. That is 192.168.2.2, then 192.168.2.1.8.8. Okay. Now same way we'll provide the IP to the router the same way. But what is the IP here? Will be 192.168.2.1. Will okay config t move to the interface int fa0 by 0 IP address 68.2.1 5.255.55.c0. Okay, no shut down. Now we have to move to this interface, that is 50.0.0.2. Okay, so AC 01/0. So okay. Okay, int AC 01/0 IP add 3.0.0.2 0 and no shut down. Okay, so see, it has been turned to green. But still, if we want to communicate within the internet for, we can do it. The message is successful, right? The message is successful. But now I want to communicate from this PC to another extra PC. It will be failed. Why it will be failed? Because I have not provided the routing. That means what? From which path it will go. From which path it will go. Okay. So until and unless I'm providing the routing protocols, that time I cannot communicate from my network to the different network. I have to provide the routing. Okay, so let's provide the routing from this PC first. So it we will use OSPF routing protocol. If you can research about the routing protocol, there are multiple protocols like OSPF RIP. Okay, I'm not going to that because that well this is not my agenda. Okay, but you can research in the internet. Okay. Okay, so what you will do? Just to router OSPF 100. Okay, then after network, then you have to provide the two network, that is 192.168.1.0, then subnet mask 55255.0. Then you have to specify a area, suppose area 1. Okay, same for another network, that is 50.0.255, so 0.0.0 and area 1. Okay, that's it. Routing is done on this router. Then you have to provide the routing protocol over here also, because I have to communicate from this network to this network, right? Okay. So router SPF 100 network 192.168.2.0 subnet mask 0 area 1, then 50.0 and subnet mask will be okay. Done. Let me check it. Yes. Okay. Now just if we now want to communicate from this network to this network, now we can do it. Okay, if we want to communicate, okay, first one will be failed as usual. See, I am communicate from 1.0 to 2.0, right? Now see, the message is successful. Okay, now I have not yet performed the NAT. Now I will perform the NAT. But before configuring the translating my private IPs, let me show you one thing. If I want to ping this different network, I can ping that. If you go to terminal on command prompt, if you write ping 8.2.2, okay, see, replay is coming. But what should be the issue? This is my private IP, right? And this private IP has been exposed to the internet. If I mean, not yet exposed, but if there is no terminology called, no concept of public IP, then this private IP would have been exposed to the internet, and my network can be malicious, right? From the malicious attackers, right? Okay. Now we will perform the NATing. So let me go to this router. That is ISP router. I'm writing the ISP router over here because ISP perform the netting, not the customers. ISP perform the netting on their own router. Okay, not the customers. So when we go to the ISP and you would say I want internet connection in my home. That at time they will automatically translate or automatically perform the netting, and then they'll provide the IP to you. Okay, so it will be performed on the ISP router. Okay, this is my global internet. So saying mentioning. This is the global internet. Okay. Now, how to do the netting? Let me exit. Okay. Now we have to write IP. Okay, I'll make it full screen. IP NAT insight. Now, what is the meaning of insight? What is the meaning of insight? Let me show you another terminology, that is outside and inside. Let me open the paint. Suppose your system, suppose two systems, okay, and two systems are connected with a router, okay. Now, if either this system is A, this system is B, okay. Now, for if we test, I am telling in the perspective of A, in the image of A. Now, if we see in perspective of A, for A, this portion, sorry, for A, this portion will be known as inside local. Okay. Now, and this portion will be known as outside local. Okay. Now, this is router. Okay. Let me write router over here. And for B, but if A is looking at B, then for B, for this portion will be known as outside global. Okay, and this portion will be known as inside global. Okay, why I'm doing that? Because I have to tell whether my interface is in the inside facing or outside facing. If it is inside, whether it is inside local or inside global. If it is outside facing, whether it is outside local or inside local. So for the time being, we are writing IP NAT inside. I'm not talking about outside now. So source. Okay. Then I'm doing static netting. Static 192.168 Uh, what must my IPs? Okay, 1.10 to 1.13, no problem. Dot 1.10. Okay. If now I have to write with which public IP I am associating with which public IP. Suppose 50.0.0.1. Okay, assigned. Okay. Now I have to assign another private IP with another public IP. Suppose 1.11. I am associating with 50.0.0.2. Sorry, 2. 1.12 with 3 and 1.13 with 4, right? That's it. Now see, well, as you can see, I have to manually configuring each and every private IP into public IP and manually translating that. So if I have 100 now, now I have to say whether which interface will be my inside and which interface will be my outside. So I will simply go int fa 0 by 0. That means my internal network. Okay. And what will do? IP NAT inside. Now, if I go to sorry, int AC0 1 by 0, which is outside facing, this one. Okay, this is my inside and this is my outside. So what I'll write, int AC0 1 by 0 IP NAT outside. Okay, now how can I check the translation? Just end this. Okay, and just write show IP NAT translations. So as you can see, 192.168.1.10 is translated to 50.0.0.1. See now, inside local, inside global. This one, because I'm talking about this router or this network. That is A. This outside local, inside global. That is why it is coming also inside global and inside local. So inside local is my that private IP, private network, and inside global is my Wi-Fi or my global internet, which I'm facing outside, right? Now, now this is translation 1.11 translated to 50.0.0.2, 1.12 translated to 50.0.0.3, 1.39 is translated to 50.0.0.4. Okay, now try to ping. Okay, 1 minute. Now try to ping from this PC to this server, which is present in a different network. Now, if we do the same thing, okay, next, wait, okay. So if I write ping 192.168.2.2, okay, it's pinging. Now, if you ping t.0.0.0.2, see, reply coming from 50.0.0.2. That means I have successfully masked my private IP within a public IP. Okay, so this is all about netting. So I think it is clear to you why we use public IP, why we don't use private IP. So now when we are using public IP, that means if you want to use the internet, that time we have to use public IP, not private IP. Okay, so I hope it is clear. So if you have any doubt, you can ask me in the comment section. Okay, So, so this is all from me. Thank you. Thank you, and thank you for looking at my show. Thank you so much.